Uh, let P be a partition of AB. So set P to be equal to x0, x1, xn with, by definition of a partition, A equal x0 less than x1 less than xn, the last one, which is just B. So now we focus on, we want to see what is the lower and the upper. First of all, check that the infimum of f of x for x between xi and xi plus 1, okay, if you look at the infimum, since the rationals are dense, this will give you 0. Okay, so you are going to find the rational in between, and therefore the function is between 0 and remember f of x is equal to x. Therefore, for the case of f of x equal to x, is going to be between a and b. Okay, so here and a and b are positive. Okay, so therefore the function will be between it's a positive function, and therefore 0 is the minimum. But if you take the supremum, okay, of f of x for x between xi and xi plus 1, so this is, we said for x irrationals, okay, focus on the irrationals, and the irrationals will give you what? For the rationals, going to give you 0. So if you focus on the irrationals, which are dense over the entire interval, and f of x is equal to x, then you will reach what? The xi plus 1 by density. Huh? Okay, so you can get as closer as you want to xi plus 1, and therefore the supremum will be xi plus 1. So if I look at now the lower sum, okay, of f with respect to this partition is going to give me 0, while if I look at the upper sum of f with respect to this partition is going to be sigma, okay, of the maximum over every intervals, which is xi plus 1 time xi plus 1 minus xi from 0 to n minus 1. And it's very interesting. This is the same as, okay, the upper, okay, sum of another function, okay, which is basically f bar going from a, b, the identity basically, to r given by x equals to x, okay? So you see, the upper sum of f is exactly the same as the upper sum of f bar over p. Now, uh, let's use the fact that f bar is continuous, and therefore the upper sum of f bar is exactly the integral of f bar. I mean, I'm talking about the upper integral, sorry. The upper integral of f bar is going to be exactly the integral of f bar, which gives us two things. Number one, the lower integral of f is going to be equal to 0, while the upper integral of f is going to be equal to the upper integral of f bar of x dx. But since f bar is continuous, this will be the same as f bar of x dx, okay, which is the integral from a to b of x dx, which is uh, b squared minus a squared over 2. So clearly this will imply what? That the upper integrals and the lower integrals are not the same, and therefore f is not Riemann integrable. Uh, it's not hard to see how one can replace the x by another function which satisfies the same properties, being positive and continuous, and you will have the same result by taking another function, like for example x squared, whatever. Okay, so there are many examples that one can generate from the same example.